Section 4.2, we want to be able to solve a differential equation. Doesn't matter about the order. The order is the highest derivative in the particular equation. We can solve a differential equation if we're given one solution. Here we want to be able to solve for the other solution. Well, if it's the other, that means that there's only two solutions, possible at most two solutions, which means that we are trying to solve a second order differential equation. Typically, the orders do suggest the maximum of solutions possible for that differential equation. So if it's order n, then we say we have at most n solutions. You might not have n solutions, but it's at most. It could be 0, 1, 2, 3, all the way up to n. So if it's a second order differential equation, and we write the second order differential equation in this form here, y double prime plus p of x y prime plus q of x times y equal to 0. The equations might not initially look like that because this equation has been rewritten such that there was possibly a coefficient associated with that y double prime. Well, if it was, we divided that through the entire equation. And so what we have left, we claim that the coefficient for y prime is p of x. This is typically some term divided by whatever the coefficient was for y double prime. Likewise for q of x. It was something else there divided by this coefficient for y double prime, as we call that q of x. P of x is important because P of x is placed within the solution for the second solution. And so we have this formula. We're going to use this formula. That is that the second solution is equal to the first solution times the integral of this ratio of e to the negative integral of p of x. P of x comes from the differential equation, that coefficient there associated with y prime, dx divided by the second solution squared. So this is y sub 1 ought to be squared. So we just solve this and we get the second solution. Okay. So this formula is known, and just use that. And here is one of two ways you can solve these problems. One way is by reduction of order. I would not cover that today. And so all I require is for you to use this formula to get the second solution. This formula is a little bit quicker to get the solution than the reduction of order. So we have some problems there. They come right from the textbook. In problems 1 to 16, the indicated function y sub 1 is a solution that's given. Use, he says, reduction of order or the formula. We'll use the formula to solve for y sub 2. So say, for example, if we take number 1, y double prime minus 4y prime plus 4y equal to 0. So we are given one solution, y sub 1 is equal to e to the 2x. So according to the formula says that the second solution is equal to the first solution, y sub 1, times the integral of e to the negative integral of p of x dx divided by the first solution, all to be squared, dx. So we look at the given problem, and so if you match it up, we want the equation to look like this, which it does. So here you can pull out that p of x is equal to negative 4. That is, that p of x is equal to negative 4. And we're given that y sub 1 is e to the 2x. So the second solution is said to be e to the 2x times the integral of e to the negative integral of negative 4 dx all over the first solution, e to the 2x to be squared dx. We just simplify. This is e to the 2x out in the front times the integral of e to the, we integrate negative 4, well, just the negative times negative is positive, so basically we just have 4 times the integral of dx. That just gives us 4x. And this is divided by e to the 2x squared is 4x dx. So y sub 2 is e to the 2x times the integral of dx. So this gives us x times e to the 2x plus some constant. Now watch, here's what we do. Let c equal to 0. I'm not throwing it away. I told you before that the constant is most important for the solution. I'm not throwing it away. I'm going to show you what happens to it, because you remember in 4.1, that preliminary theorem, which was actually the superposition principle, it takes into consideration those constants. It takes into consideration those constants. In other words, all I'm saying to you is this, is that y sub 1, which is given, is e to the 2x. And y sub 2 is x times e to the 2x. I'm telling you that, and so that's what happened to the c, because the solution is that the complementary solution, because we're solving a differential equation which happens to be homogeneous, right? The differential equation is equal to 0. It's homogeneous. So the solution that we call there is a complementary solution. It wants to really complement another solution, which would be the particular solution for the non-homogeneous differential equation. Here we're only considering the homogeneous differential equation and its solution. So I say y sub c is equal to, remember how we write it, is c sub 1 times y sub 1 plus c sub 2 times y sub 2. There goes our constant. So your solution is c sub 1 times e to the 2x plus c sub 2 times x times e to the 2x. Okay. Let's look at another one. So for example, if you take number 3, y double prime plus 16y equal to 0, the first solution is said to be cosine 4x. I think I wrote that down correctly. Yes. So we say that y sub 2, the second solution, is the first solution, cosine 4x, times the integral of e to the negative integral of p of x. What's p of x for this particular problem? What's p of x? 0, right? P of x is associated with y prime. It's the coefficient for y prime. There is no y prime here, so its coefficient is 0. Remember again, it's y double prime plus p of x, y prime plus q of x times y is equal to 0. So for this particular problem, p of x is 0. Right? So this is 0 dx all over the first solution, and we square that. So we get cosine 4x times the integral. Here, this is I'm integrating 0, so I don't have anything. This is e to the 0, so this is just 1 all over cosine squared 4x dx. So when I flip that, I have this second solution. It's cosine 4x times the integral of secant squared 4x dx. So what is the integral of secant squared? It's tangent. Cosine 4x, this is times tangent 4x plus the constant. Here let c equal to 0. Y sub 2 is equal to sine 4x. Everybody happy with that? Yes, sir. Tangent is sine divided by cosine, right? So cosine's 4x cancels out. There you go. And you're going to notice with the oscillation of these trig functions in terms of cosines and sines, they tend to go together in terms of derivatives and integrals. And then also secants and tangents tend to run together in terms of their integrals and their derivatives. So for the solutions for a differential equation that combines or that has a cosine, if it's a higher order differential equation, more than likely you will have a cosine and a sine that will accompany. They're going to kind of run together. So your solution then, y sub c is equal to c sub 1 times cosine 4x plus c sub 2 times sine 4x. Okay. Any questions? Let me do one more here in this section, and then we'll move on to 4.3. Yes, number 9. Number 9. X squared y double prime minus 7x y prime plus 16y is equal to 0. The first solution, y sub 1, is given to be x to the 4th. What is p of x? What is p of x? Negative 7 over x. You see that? For this problem, you see the x squared that's associated with y double prime? You have to divide that term through the differential equation. For the previous couple of problems, it was already done, right? So you want to be careful. So this implies that this is y double prime minus 7 over x y prime plus 16 over x squared times y is equal to 0. So P of x is equal to negative 7 over x. So then y sub 2, the second solution, is the first solution, x to the fourth, times the integral of e to the negative integral of negative 7 over x dx divided by the first solution, all to be squared. Be very careful about P of x. Make sure you look at that term that's multiplied to y double prime. This is x to the fourth. This is the integral of x to the seventh, just lost somebody, over x to the eighth dx. Okay, who did I lose? Okay, Jason, how do we get that x to the seventh in our numerator for our integrand? Now I'm just joking. Do you see where we got the x to the seventh? So we're all together. Right, Lauren? Okay, how did I get the x to the seventh, Lauren? Okay, so you just told a story to a preacher? Well, it doesn't matter. Preachers tell stories too, so mercy, Lord. Oh, boy. Now look, folks, this is the laboratory. If you got a question, ask. I'm not going to bite your head off. Matter of fact, I get happy when you ask questions. I get sad and upset when you don't ask questions. Because I hate to come through here and say, you have any questions? You say no. You say no. Everything's okay. Then I give you a test and you make a 41. Then I get upset. You know? How come you didn't ask me a question? That's why we're here. Yes, sir. I can't answer your question. I don't have time. No, I'm just joking. Yes, you take the integral of, you get rid of the negatives, right? Negative times negative cancels out. And so you can pull the 7 in front of the integrand. So you have just the integral of 1 over x dx. Well, that's the natural log of x, right? And so that becomes 7 times the natural log of x, which is the natural log of x to the 7th. So it's e to the natural log, right? Which only remains just x to the 7th. Right? So all you have for the numerator is x to the 7th divided by x to the 8th. Now you want to probably go in and put in your margin what I just said, right? Because you go back and look at that, you'll say, oh man, how did he get this x to the 7th? So 1. Okay. So, yes, y sub 2 is x to the 4th times the integral of 1 over x dx. And so this is x to the 4th times the natural log of x, and we don't know the value of x, but it has to be positive for us, plus some constant c. So we take y sub 2 to be x to the 4th times the natural log of the absolute value of x, and we conclude that y sub c, the complementary solution, is c sub 1, yes, times x to the 4th plus c sub 2 times x to the 4th times the natural log of the absolute value of x. Any questions? And please, I'm serious, ask questions, because just as sure as you're born, somebody very close to you that probably has the same question, and They're not going to answer either. Yes, sir. Yeah, that's why I said just take y sub 2 equal to x to the fourth times the natural log of x. That statement there is inclusive of letting c equal to 0. Yes, sir. This is the laboratory, folks. It's the laboratory. Right? You can make mistakes in the laboratory. Right? Thomas Edison, when they were working on the experiment for the light bulb, it is said that they tried, it was very exhaustive, over 1,000 times so many experiments on getting this carbon filament to light and to stay lit. And they tried and tried hours. They said that Mr. Edison wouldn't even sleep for days. They just stayed right there in the lab and just worked. And when they finally got the filament to keep its charge, one of the young lab techs, just a young student, probably in his late teens, 19, 18 years old, came from where they were. He had to take that upstairs to the other lab so that they could connect that carbon filament inside that enclosure for the light bulb, and it was very delicate. And so he walks up the stairs and he drops it. and over thousands upon thousands of tries and hours of trying to get to that one that actually worked, this young guy dropped it. And so you could imagine the people in the lab, they were hurt, upset, frustrated. And so they tried and tried again, and tried again, until they finally got another one to work. And Mr. Edison looked at that same young lab tech and said, "Young man, take this upstairs." You know why? It's the laboratory. We make mistakes in the laboratory. So if you don't know, you ask. We'll try to, Lord's willing, help you out. Okay? Any questions here for this section? That's all you have to do. I give you the formula, and then you just use this formula. And I ask the question, given this one solution, can you find another solution? Just plug that right into the formula. Okay? Yes, sir.
So the solution, the second solution, the last set off the test, is it going to be complementary or y sub 2?
You're doing two things. You're getting y sub 2, but then you're also writing the solution for the differential equation itself. And the solution for the differential equation combines both of those, y sub 1 and y sub 2, right? They both solve the DE. Yes, sir.